We are Group 3 and we will be presenting on Topic 4, the phenomenon of order and periodicity in everyday life. So these are a table of contents. So for introduction, what exactly is the phenomenon of order and periodicity? It refers to the tendency of the arrangement of atoms or molecules within a material to recur at intervals, forming repeated patterns, and they're often classified into two types, crystalline or amorphous. So why is this important? How atoms are arranged affect the properties of the material, which vary according to what the intended purpose of the material is. This also helps to forecast weather and predict how elements interact. So the two examples that we'll be going through are textiles, where summer and winter wear will be covered, as well as structures such as honeycomb and spiderweb.
Next, we'll be talking about the order and periodicity of textiles and how it affects them. We'll be discussing about how the order and periodicity affects the clothes we wear during the summer and in winter. Have you ever wondered why we wear cotton shirts when it's hot? This is because of the periodic arrangements within the material. Cotton clothes are made out of plain weaves that contain visible gaps between the threads to allow air and sweat to escape. This gives it the loose structure for air to pass through easily, making it light and breathable. These weaves are evenly spaced with uniform periodicity and have a repeating pattern of threads that create a regular grid-like 2D periodic lattice where air can flow and moisture can evaporate. Cotton shirts are also made from cellulose chains, which are composed of repeating glucose molecules, and these chains are packed into microfibrils, which contains crystalline regions that are tightly packed, thus giving the cotton shirt its strength and durability, while also containing amorphous areas that are less ordered, allowing flexibility and water absorption. This draws sweat away from the skin.
Look at the order and periodicity in winter clothes. The weaving method commonly used is twill weave, which is order of interlacing in which diagonal lines of warp and weft flows are formed in the fabric, as we can see in the picture. The order is directional order of distinct diagonal weaving, and it has longer periodicity due to larger repeating unit compared to plain weave. This results in good material properties, such as good heat insulating abilities, enhanced durability, good wrinkle resistance, flexibility of drip, and good stain resistance. And this is commonly used for wool, trench coat, and denim jeans. When we look at wool fiber, which consists of keratin protein, it is semi-crystalline keratin structure which is a mix of ordered and amorphous regions. The ordered regions, alpha helices, provides elasticity, while amorphous regions provides air trapping. It is semi-periodic, which means it's arranged hierarchically, thus providing natural cream that traps air, thus providing warmth. The order and periodicity of wool fiber causes good thermal insulation even when wet, and is fluffy and warm when worn. This is why wool is very common in winter clothes.
Okay, next we're gonna take a look at the examples of where we see order and periodicity in structure. The structure is a honeycomb or hexagonal structure. Honeycomb structure is a geometric arrangement consisting of repetitive hexagonal cells. Honeycomb structure gives incredible strength and stiffness while being so lightweight. The honeycomb core provides high shear strength and compressives, while the fasciates carry the primary tension and bending loads. Its hexagonal shape, maintaining equal loads, pass in all directions. Any external force applied from different directions spreads evenly through the structure. It's also the most efficient geometric shape by leaving no gaps while minimizing perimeter length. It fits together perfectly, ensuring 100% space utilizations, and is also used for spacecraft, architecture, and industrial applications.
A spider's web is a tension-based structure made up of delicate radial and spiral threads that work together in perfect balance. This unique pattern allows the web to spread out any force evenly, giving it incredible strength while staying lightweight. The radial strands hold the main structure, and the spiral threads stretch to absorb shocks, preventing the web from tearing easily. Even though it looks fragile, spider silk is actually stronger than steel when compared by weight. This remarkable natural design has inspired humans to create innovations like bulletproof vests and suspension bridges, using the web's balance of strength and flexibility as a model for modern engineering. Now, I'm going to conclude our presentation. This table presents the summary of our presentation. The honeycomb structure is the most efficient geometry shape, and the spiral web structure is extremely strong.
Cellulose chains and plain weave arrangement largely affects the durability, moisture management, and thermal behavior fit for cotton shirts worn in summer. Keratin protein is found in wool fiber. Its order and periodicity provides useful properties such as thermal insulation and breathability. This makes wool clothing really suitable for winter, as it gives warmth and comfort.